anaerobic bacteria. It's enriched media. Then this media used for isolation, previous sample, bacterial isolation from first sample, and for enriched APU culture. It's a liquid media, contained maybe of it meat, cooked meat, on the 1% of glucose, peptone water, maybe sometimes may add 0.5% agar. Before cultivation, this media is heating for removing oxygen, then covering with Vaseline oil for stopped sorption oxygen. As a result, in the middle of this formation, anaerobic conditions. What anaerobic bacteria we study? Class 3D, yes, class 3D Tetani, Botulinum, Clostridium perfringens. So please diagnosis for class 3D. The next media also for anaerobic bacteria is Wilson-Blair agar. It's media used for isolations euculture. It means to add a separated colonies, because if we add bacteria in this, we don't know how many types of bacteria are present. We cannot isolate a euculture, isolate separate colonies. On this medium, we may add isolation colonies, a black color. Why it's black color? It's also contains 1% of glucose, agars, and sulfite, natrium sulfite, and ferrum chloride. Natrium sulfite and ferrum chloride. If anaerobic bacteria present in this media, it starts to destroy glucose. After destroyed glucose formation, acid. This acid initiate reactions with natrium sulfite and ferrum chloride. Result of these reactions, ferrum sulfite a black color formation. Ferrum sulfite a black color in the place of multiplication bacteria. As a result, we can see a black colonies. We make isolation these colonies, and the next study and the next active euculture. Is it clear? Biochemical characteristics. The next, anaerobic mannitol fermentation, safe fermentation, anaerobic mannitol fermentation. Absent. Then it's a test for describe pathogenics for differentiate Staphylococcus aureus, especially differentiate pathogenic, non-pathogenic Staphylococcus. Then pathogenic Staphylococcus aureus destroy glucose and mannitol, for example, in aerobic and in anaerobic conditions. Then and this result of destroyed pathogenic, yes, Staphylococcus, which destroyed, change the color from pink to blue in anaerobic conditions. This pathogenic Staphylococcus. This non-pathogenic Staphylococcus, because it don't destroy color in anaerobic conditions. Is it clear? It's test also for Staphylococcus. It may be combined. You may give on modules, yes? One petri dish, other this test, and ask you what is this. You may say that it's a test for isolation Staphylococcus and test for biochemical test for identification. Is that clear? The next test, stage, yes? Stage fermentation. Its test may use, for example, for Corynebacteria and diphtheria. Yes. Yes. for example, biochemical test positive for BOVAX, Carinobacterium diphtheria gravis, and negative for Carinobacterium mitis. That it also differentiates test positive with a pink color because in this media we stage as indicator, and if it's negative, it's remain a yellow color. The next. Oh, it's also this test maybe it's a similar for Voges-Pascal reactions. Voges-Pascal fermentation of acetyl methylcarbinose. It's test also for differentiated BOVAX but Vibrio cholera. Open the please at home for this Vibrio cholera. Then for test for acetyl methylcarbinose. It's a Voges-Pascal reaction. It's positive, also pink color, formation acetyl methylcarbinose. And for BOVAX Vibrio cholera L-tone, and negative for Vibrio cholera classic. Is it clear? It's also biochemical test for. It's a visual. It's a similar with test for starch and test for Voges-Pascal. Okay, and then triple sugar agar. Yes. Triple sugar agar. It's a specific differential medium. And for identification enterobacteria, it contains what? Glucose, lactose, sometimes sucrose, and it's indicator morate salt maybe for produce hydrogen sulfide. Then this maybe in general, what in general, how to change the color of this. We don't, please don't look on sucrose because on this is also negative, then we don't look for enterobacterial sucrose. We fixate change or no, destroy or no lactose and glucose. Then, if I change the color, I make change the color. It's a usual what? To specific food media, then should be present step and slope. And cultivation bacteria in step and on the slope. Then, if I change the color on the step, it means glucose positive. If I change the color on a slope, change the color from pink to yellow. From pink to yellow. It's also. Then it means lactose positive. And if formation black green in the middle between slope and step, then bacteria produce hydrogen sulfide. Is it clear in general? That's why this media very often used for isolation pure culture and identification because it helps to add several biochemical tests. Then, example, this E. coli. Why? Because it destroys glucose and destroys glucose with gas. Can you see? Bubbles and the media of the top. destroyed lactose, change color, non-formation hydrogen sulfide. Then a triple sugar with E. coli. Other Shigella. It destroyed glucose, don't destroy lactose. It's very old, but it's in color. Then it's don't destroy lactose. Is it clear? It's Shigella. And this Salmonella, typhi or paratyphi B, because paratyphi A don't produce hydrogen sulfide, and this is Salmonella. It's changed to yellow, yes. Very many hydrogen sulfide. Then it's destroyed glucose, don't destroy lactose, and produce very many hydrogen sulfides. This is Salmonella. Is it clear how to use this media for differentiate E. coli? Okay, next. Phage sensitive tests. Maybe today's topic also. Do you remember what is this bacteriophage? It's viruses which, yes, it's bacteria because it's parasitic bacteria. And it's a very specific property, specific viruses, cultivation only specific group of bacteria in one species and not in all maybe species. Typical bacteriophage growing only in specific phagotypes of bacteria. This property used for finding source of infection. For example, if it's an in-hospital infection, or if it's complication after surgery operation, Staphylococcus aureus, nosocomial infection. Try to find where is this source of infection. Take material from patients, from one petri dish, other, for example, from nurses, other from best sterilizing instruments. Isolation bacteria spread that is covering on all petri dish. Then marked a bottom of this petri dish. Add typical bacteriophage in standard preparing present in laboratory in each of these. Depends what number. Cultivation 1 day. After 1 day, we check results. We check what bacteriophage lies in this bacteria. What phagotype of this bacteria. The phagotype of this bacteria is number of bacteriophage which lies in this bacteria. This 6, 77 and 53, and this only 55. Different phagotypes? Yes, different. Yes. This 6, 77 and 55. Is it clear? Then it's different phagotypes. But if you take other petri dish, it's 6, 7, 53 and 77. Then it's a same phagotype. What does it mean? It means this, for example, for these patients, source of infections is this bacteria. Yes, because it's same phagotypes. It's very specific properties. Is it clear? Then you should decide what's the test, phagosensitivity or phagotyping. You said why we use this test. It's for find source of infection. Yes, you should be described how to put this test and how to read results. Special is nosocomial infection and hospital infection as staphylococcal infections. The next antigenic properties testing in Ascoli reaction, gel precipitation test, light agglutination test. Ascoli reactions, it's reaction of precipitations. Reaction of precipitation. Okay. Now we stopped and then gel precipitation test, light agglutination. Okay, gel precipitations. I now